Okay, so once again, you're most welcome, and we are in here for item 2, chemistry 2024, that Uneb paper. Want to see how the responses are meant to be, and also the score allocations for each and every part. Let's go there. So that's the Uneb scoring guide for item 2, paper 1, chemistry. Okay, so please, you can share, like, and comment. Please make sure that you share this video to some other person who may find it important, such that we help one another, because I know some people may not know how the scores are done as far as chemistry is concerned. All right, so please, you share to the friends, such that we all get to know how this is, okay, in simple terms, done. Now here, this scoring guide, I'm just going to go direct so we can avoid wasting time. Let's go there. So this is the scoring guide for item 2, and that's how everything is meant to be done. Now, just like in item 1, we said part A and part B are marked based on category and function. Okay, part C is marked based on danger, whereby in danger here we looked into the danger identified, danger explained, and danger mitigated. Of course, for category and function, maximum score is 6. That's part A, number 1. Okay, for part B, which talks about function, is in fact part A and part B, maximum score is 6. Part C, maximum score is 6 also. So let's look into part 2, or rather item 2. Now item 2 is settled basing on, okay, item 2, the rule is give a category, a reason, and the example. In fact, let's go here. So you see that here on part C, they will give you category, a reason, and a example. But please take note, only category and reason are scored. Like only category. If someone just gives an example, then that can't really work. In fact, I don't know if I can still get an example on this, such that we can get to know what was meant to be done here. Like say for example, a category here, this item 2, when you look at the areas of construct, please, this item 2, when you look at the areas of construct, maybe if you can try to look into that. Okay, this item 2, okay, the areas of construct is that areas of construct here, we must look at the category of a product, functions of a product, dangers and effects of a product, and then evaluation. That is item 2. It's a bit similar to item 1. Like, still allow me, in number 1, I used the other sample guide of last year, or in fact the sample paper of last year, Uneb. Okay, I remember, I think if you try to check in item 2, last year's sample paper of chemistry was talking about something to do with the, okay, cement, no, not cement, but okay, it was talking about something to do with the rocks. In fact, it was talking about something to do with the rocks. Now I'll be making a video to such that we also look into how the areas of construct are stipulated basing on the items, and we shall have that video also in our playlist. So now last year, like, they set a question about rocks. So a category is that you give the elements. So let's look into this and get to know how we can get this explained. So this one is So we have CR, CI. Now CR means material or category with reason. CR means the material or category with reason. CI means a category or substance identified. So identifying the category, then here a category with reason. Yes, that's what I'm meaning. Now here, when you have a category with a reason, then identifying the category. Identifying meaning, like say for example, if they talk about okay, if they talk about say for example, if they talk about okay, rocks, we know that rocks, okay, if they talk about rocks, you know that some rocks may contain some elements in them. Like say for example, when you talk about limestone, limestone has got calcium carbonate in it. So that's what I mean by category identified. Okay, now here you must now come and tell us the properties. You must now come and tell us the properties here, properties and use. So in the first context, if you give 3 properties, now here you can give 3 to 4 properties. If you give 3 to 4 properties plus 1 use, then you have maximum score of 5. By the way, maximum score is 4. Take note. Here, once you give the 3 properties and 1 use, you have score 5. But if you give 3 properties without use, if you give properties only without use, then you get 3. But if you give 1 to 2 properties and 1 use, you get 3 still. So the properties must be 3 and above, and 1 use 5. But if you give 1 to 2 properties and 1 use, then you get 3. And if you give 1 to 2 properties without a use, you get 2. And once you give 1 use without a property, you still get a 2. I hope that really makes sense. The word P means property, the word U means uses. And maximum score there is 5 marks. Now we must see the dangers to the environment. Of course, we know that in chemistry, each time we see a danger, we must be there to solve it. So here will be MI and we have MM. MI means impact of the human activities. You identify the impacts of human activities. Then MM is a mitigation. Is the way we can solve. Like say for example, danger is that quarrying may lead to soil erosion. How can we solve that? Okay, shall be looking into that. Now I want to still comment. I want to still comment on this using the other some paper of last year. Okay. Now the paper of last year, if well, I don't have it here, but I think I can remember what they had said there. The paper of last year, in fact, they had given, in fact, a picture. If you can remember, there was a picture containing iron sheets. Okay, a lot of things, in fact. But in the item today, someone wanted to construct. We had iron sheets and we had very many things. So somewhere I think they were asking the categories of materials in there. The categories of materials, of course you can say category there, but you must give a category with the reason, of course. And of course there, if I try to recall, okay, if you try to recall what they are given there, we had the rocks, a lot in the picture. Then the categories of materials. Now here, we all know that the categories of materials, we have the synthetic materials, which we call the artificial materials, and the natural materials. Now, in the picture, I think if I remember, among the natural materials in real life, we have rocks, sand, wood, and water. Now that's what I'm meaning, a category with an example or reason. So in this area here, we would come and give this. In this area here. So I'm giving category with reason or example, or identifying the category. Identify the category, natural material. Now a category with reason or example is, okay, natural material, in there we have rocks, sand, wood, water, and soil. Okay, still again, artificial materials, that's a category identified. Then we have there all synthetic materials or man-made. You can say the bars, the metal bars they use for building, the plastics, the paint, and also the composite. Yeah, that is it. So that will really answer this part. So if a student gave a category, natural, identified natural and artificial, but came and gave us a reason as why he's saying natural and artificial, whereby natural we said wood, rocks, and soil, while the artificial we said paint, plastics, and bars. So that's what we mean, okay, by that part, category with reason. So the student qualifies to get 60 marks. And also, please, in that area, you may it must be enticed. Like, in order to get all the 4 marks, you must give 3, these 2. Identifying the category artificial, natural. Giving a reason. In natural, an example is soil, water, sand. In artificial, we've got iron bars, plastics, paint, and composite. Let's move to the next part and we see the way forward. Okay, sorry for that. Okay, I want to erase off this first. Okay, now let's see another color. So done with that. So the maximum score there is 4. CR means that, CI means that. Let's go to the next part. Now these are properties. Now what are the properties of some of the, okay, here we have talked about the natural and artificial materials. Among them we had the bars, soil, rocks, and so on. Now here can come and talk about one by one. Now I can get an example here which you gave, like say for example iron. You know that iron is very strong. That is a property. Property means a behavior. So iron is very strong. And how important is that strength? If iron is strong, how important is the strength of the iron to us? That's a property and use. So iron is strong. Iron is strong, so it can be used to support heavy load. That really works. Then also iron is ductile. Now ductile means that it can be bent. Like if they can bend it and make any shape they may want. So like that. You can talk about wood. Wood, we can say that readily available. Yeah, wood is accessible anywhere. Okay, more so in the village areas. Then also wood is also strong, therefore can support heavy load. Of course, when they are constructing a house, they may use wood. That's what I mean by property. However, here you must, in order to get all marks, you must come and give 3 to 4 properties with 1 use that works. Okay, then you have the 5 marks. So a 5 plus 4, that would be 9. The next, the dangers. Can there be any danger with these things here? Okay, can there be any danger? Yeah, now we must give a danger, but here we say from item 1 that you give a danger and also mitigate it or provide a solution to problem. Okay, in this area, and you see that when you add 4 plus 5 plus 3, the highest score for item 2 is 12. Though, however, still, in item 2, please, they may also set a calculation. Moral concept also can be examined in this area, but more to come in the areas of construct chemistry. You'll be checking in the playlist. Please be reminded that on our channel here we have a lot. You can go in the playlist and check out for more important work. Share such that some other people also don't miss out. Subscribe to help this work going. Okay, let's now move to the next part. So let's go through this the thing. Let me get this pen. So an industry wanted to produce lime. Okay, we would underline this word lime. Okay, to produce lime for treatment of acidic soils. The production of lime involves heating limestone, so limestone, strongly, which results into decomposition according to the equation. Now, this calcium carbonate is limestone, so this arrow means we are heating, and then we shall get calcium oxide, and then, okay, carbon dioxide. Let's proceed. The procedure is also interested to know how much gas is evolved during the process, since the gas is useful. By the way, carbon dioxide is useful. Before the production, an experiment was performed where 25 grams of limestone, but of course the word limestone also means calcium carbonate. Take note of that. So we heated, okay, to make it follow up, we heated until there was no further change. Okay, good. Then you have been contacted for help. Task: as a learner of chemistry, explain the categories of the products. Now we must explain the categories of the products. Here, that is now part A, and we saw the marking the first part must be about the categories of the products. Now, a category must give the behavior of the product we have. Like, say for example, the products, category of the products we have, there are two. We have calcium oxide, take note, and we have carbon dioxide. Please take note, this one is the produced, so these are the products. These are the products. The ones I'm circling there are the products. So what are the products? What are the products, or rather, what are the categories of the products? Okay, let's go there and categorize. Let's see. Start off. Okay. Okay, so there we are. Let's now see, and I think let's see the marking areas also, so that we can go at once. Okay, now those are the marking areas. Then let's start off. We go through it slow but sure. Let's see. So we have that the product is calcium oxide. Of course, we have identified that. We must talk about that. The product is calcium oxide, which is an anionic compound. So you have identified the category. Okay, you have identified the category. The product is calcium oxide, which is an anionic compound. Ionic compound means, okay, part of it, because when you look at calcium oxide, calcium is a metal and oxygen is a non-metal. So that one is an ionic compound. So that we put there, the category has been identified. Now we must give a reason. Because it is formed, okay, we are giving a reason. CR means a reason. CI means we are identifying. So we have identified it is calcium oxide and it's an ionic compound. We are giving a category. It is an ionic compound. Why? It has part a metal and non-metal, just like from the word ionic bonding. So ionic bond is a bond formed between a metal and a non-metal. That is calcium and oxygen. So it's an ionic compound. That's a category we have identified. Because now this is CR, a reason. Because formed by complete transfer of electrons from a metal atom to a non-metal atom, or by combination of a metal with a non-metal. Now realize that when you get calcium, remember, okay, calcium has electronic configuration, okay, how much? Okay, 20, electronic configuration 20, which will give us 2 to 8 to 8, okay, then finally 2. That's calcium. Then how about oxygen? Oxygen, I think oxygen has 8, so 8 will be 2 to 6. Okay, I guess you can see that. So you realize that when you are combining to form a bond, these 2 outside will combine with this 6 here, like that. That's why I'm saying that formed by complete transfer of electrons from a metal atom to a non-metal atom, or by combination of a metal with a non-metal. Yeah, reason is why ionic bond, because ionic bond is a bond which is formed between a metal and a non-metal. So that's the reasoning you can give. First of all, identifying the product is calcium oxide. Category is how do you get calcium oxide? Through which kind of bonding? Okay, it's an ionic bond. Why ionic bond? It's a bond formed between metals and metals. Or if you don't have that, you can say calcium oxide is a basic oxide, because there are very many categories. You can talk about calcium oxide in very many ways. You can say calcium oxide is a basic oxide. Now basic oxide, these are oxides of metals. Yes, because we have basic oxides, acidic oxides, amphoteric oxides, neutral oxides, and so on. So calcium oxide is a basic oxide Now we must give a reason, because it reacts with water to form an alkaline solution. So you can either give this version, or you can give this first version from here to here, all your choice. So you can categorize it the way you want. That it means that you must be well versed with some of the information as far as some of the oxides are concerned, depending. Last year in the Uneb sample, in this question part, they brought something to do with the the board question is a question from using materials, totally different from this. So you must be well versed with almost every topic, such that you can be able to answer some of these parts. Now next, that's the first thing. Now of course here, this will be now the, okay, this first tick will be the CI, and this one here is the CR. Please, we told you must give like 3 points in every area. This is the first one together. This is just the O part of it, don't get confused. This part here is giving us what we have written in this area. Okay, good. Now we say the second product is carbon dioxide. Remember I talked about calcium oxide. Please let's go and see it from here. Some people may not see. So the product is after this arrow. In an equation, after the arrow, what we form on our right is what we call a product. So you have calcium oxide. Okay, erase this. You can all see that we have here calcium oxide as a product. We have carbon dioxide as a product. We have finished talking about this. How do we talk about it? Identify it as calcium oxide, categorize it, then give a reason. Okay. Then we are going next to carbon dioxide. We get to know its science. So the same. The second product is carbon dioxide, which is now, which type of oxide is this? It's an acidic oxide. Please be reminded that an acidic oxide, these are oxides of non-metals, which when mixed in water, okay, can end up forming acidic solution. It is an opposite of what we call the basic oxides. Okay, it is an acidic oxide. But then, which kind of bond exists between carbon dioxide? Remember, if you look at this, okay, sorry. Now I think here we have carbon, which is an nanometal, oxygen, which is an nanometal, and now the type of bonding which exists between nanometal, we call it a covalent bond. And now you must also talk about that. So you're saying the second product is carbon dioxide, of course, which is an acidic oxide. Why acidic oxide? Because these oxides of nanometals, and carbon and oxygen are nanometals. Then also, and a covalent compound from the word covalent bond, because it is formed by sharing of electrons between nanometals. That's the reason we bring. Okay, carbon and oxygen, for example, sulfur dioxide. Yeah, now here you can entice it and give another example of what we call the acidic oxides. Among the acidic oxides is sulfur dioxide. Here another example you can give about basic oxides. You can talk about it. Okay, you can from after calcium oxide, you can give another example of what we call basic oxides to entice it, because here we said here that in this table you can give a category, reason, and example. So give a reason, so you can even give an example where necessary, and that marks the end of that. So it is an acidic compound because it reacts with water to form as carbonic acid. Okay, yeah, this is a bit simple. So you can say it's an acidic compound because it reacts with water to form acidic, okay, acidic solution. An acidic solution, that also can work. The marking goes the compound category with reason plus the category identified gives us a total score of 4. So here you have 4 marks for that area. Why? 2 for talking about calcium oxide, 2 are for talking about carbon dioxide. Let's move to the next part. That is part, okay, part B. There we are. So suggest the properties of the gaseous product that makes it useful in your daily life. So the gaseous product, if you can see here, please go back. Okay, the gaseous product is carbon dioxide. Now they want us to give them the properties of carbon dioxide. Let's go and see. You all know this. First of all, it is colorless, it is odorless. Now some people take the confusion that carbon dioxide has a smell, because some people know that any bad smell means carbon dioxide. Please, it is not the case for that. Carbon dioxide is odorless, or in simple terms, it has no smell. Okay, let's move on. So you have that. we shall put the marking areas also, and we say the way, okay, forward. Shall put the marking areas at once, then we explain. Okay. Okay, great. Okay, so far we have that. Let's now go through that. They said suggest the properties of the gaseous product that make it useful in daily life. So we shall say that carbon dioxide is a colorless and odorless. Now, as we are marking part B, I want us to look at this. As I'm marking part B, let's go and see. We use property, use. Property, use. Then they said, okay, come and see this. Here they say that, okay. Here they say that once you give 3 to 4 properties and 1 use, you qualify to get all the marks. So means that question shall give like 3 properties and 1 use of carbon dioxide. 3 properties of carbon dioxide and 1 use. Then we say, okay, that's enough. But I said, to avoid these letter names, you can just put a tick. Then you put 5. That is if the student is given as per that. You put a tick and put 3. If a student is given as per that, you put a tick and give 3. As if a student is put as per that level, give a 2, give a 2 again. Like that. So let's go back and see. Okay, so carbon dioxide, let me get a laser pen here. Okay, carbon dioxide is a colorless and odorless. Okay, that's a very good property, thus ideal for use in food and beverages as preservative. Yeah, of course, you have all ever. Now this one here is U. Put a tick and U, that is a use. This one is a property. So 1 use, you may not give any other use. The rest can be properties such that you get the 5 marks altogether. Next, it does not support burning. Yeah, that is very true. Thus used in fire extinguishers. So are you seeing? You talk about a property and how is it applicable in real life? Does not support burning, used in fire extinguishers. Okay, dissolves in water. This allows it to enter plant cells for photosynthesis. Yeah, as the plant roots are absorbing water from underground, the water absorbed goes with the carbon dioxide, which supports the photosynthesis. Lastly, reacts with water, chlorophyll to produce glucose and oxygen. Now this one is more of biology, but you all know that chlorophyll is the green pigment, and of course that green pigment enhances the production of glucose and oxygen. That is after photosynthesis process. Glucose plus the oxygen, then okay, in here it's more of the biology. They will get the under chlorophyll. In fact, sorry, what is this? Okay, let's get this done, clear up this. So yeah, saying that dissolves in water and this allows it, okay, yeah, beyond this, reacts with light, water, chlorophyll to produce glucose and oxygen. This through the process of photosynthesis, like that. These are all properties and their uses. Properties and their uses. Now, like here, this one is a property. Now, okay, does not support burning is a property. Then use is this. So this is here would put P, and there you put U. However, I can just put a tick and then your word. Okay, a mark. Then here, the end of the story, you have to get 5 marks. Okay, this is meant to have 5 marks, though I didn't put it there. Let's move on to part C. Now remember, in the question here they said, here in the question that, okay, was performed where 25 grams of limestone, but limestone is calcium carbonate. Okay, let's move on. So let's proceed with this area. So bring back our equation. So RFM, the relative molecular mass of carbon dioxide is of calcium carbonate is calculated as follows. Please, you realize that at the beginning when you you go back and watch item 1. Item 1, we explained that they gave us some values for some of these elements here. Like say for example, like say for example, calcium itself is 40, carbon itself is 12, and the oxygen itself is 16. The RFM of calcium is 40, the RFM of carbon is 12, the RFM of oxygen is 16. But why the multiplication? Why multiplying by 1? It's because here we have only one calcium. You can see that. So that's why I say that now a 40 times 1. Here C, why times 1? We have only one carbon. So times 1. Why are we having here? Okay, we have here 3. So we shall say 16 times 3. And then the whole sum you get, it will be 100. Okay, 100 grams. That's what we have. Next. Now we all know that 1 mole of a gas, or 1 mole of calcium carbonate, decomposes to form 1 mole of carbon dioxide gas. Now what am I meaning by that? When we look at this, here we have the coefficient here is 1, and even here the coefficient is 1, and our point of emphasis is calcium carbonate and carbon dioxide. So you realize that 1 mole or one mole of calcium carbonate reacts with 1 mole of carbon dioxide. The word 1 we are getting it from this coefficient before, a number before that statement. So 1 mole of carbon dioxide, calcium carbonate produces 1 mole of carbon dioxide. That's what we have here. Then let's move. But we all know that 1 mole of a gas has 22.4 decimeters cubed at certain temperature and pressure. Please go in item 1, the beginning part. We explain where those ones come from. They were given there on the question paper on top. So 1 mole of carbon dioxide contains 22 cubic centimeters of STP. So it means that 1 mole of calcium carbonate, since everything is talking about 1 mole of carbon dioxide, now 1 mole of carbon dioxide has this. So it means that here also 1 mole of carbon dioxide. So in this place here, you can just substitute it with this. So therefore I can say 1 mole of calcium carbonate decomposes to form 20 cubic centimeters of carbon dioxide, so that you can easily relate. Let's move on. Okay, now let's do our table. I prefer using the first principle approach. The first principle approach. This simplifies. Now remember here, we are talking about only, okay, about this. We are talking about calcium carbonate and carbon dioxide. So the ones I'm going to put in my table. So here we go. Mass and volume. Let's now see that now the mass and volume, look, carbon dioxide is weighed in terms of volume. So this one here talks about carbon dioxide. I will use the C. Okay, carbon dioxide is CO2. Then mass given to us was of calcium carbonate from the question. So this one here is calcium carbonate. Allow me to write it like that. Okay, so let's see. So 100 grams of calcium carbonate produce 22.4 decimeters cubed of carbon dioxide. Why? So it's because 1 mole of carbon dioxide gas, 1 mole of carbon dioxide gas, same as this. So if 1 mole of calcium carbonate produces 1 mole of carbon dioxide, then you can rate from here. I've explained that. So 100 produces 22. What about now the 25 will produce how many? This side, that's a question mark. Let's now go and calculate now. The calculation here goes this times that, this times that, and that will be a 22.4 in simple terms times a 25, okay, divide by 100. That's what is meant to be done here in simple terms. Let's see. Put the ticks there. So we use CA since we are getting the categories and we are applying CA. We are applying the the products. Like say for example, we are having here the calcium carbon dioxide and calcium carbonate, and we are applying. So we use CA. So let's see and complete up. Okay. We have that. So we're now comparing from this. So now say that 100 grams of calcium carbonate produces 20 cubic centimeters of carbon dioxide. That's where you're getting the song from. Okay, 100 grams of calcium carbonate decomposes produce 20 cubic centimeters of carbon dioxide. The next step is going to be 25 grams of calcium carbonate will produce, then we see the way forward. Allow me to resolve this. So 25 grams of calcium carbonate will be, now you multiply. So here what you are doing in simple terms, we get this. In fact, after writing that statement, we get this. We get this, multiplied by that, then divide by this first one which began. You get this multiplied by that. Now, okay, so 25 grams of calcium carbonate decomposed to produce 20.5 times 25 over 100 decimeters cubed of carbon dioxide. Let's see who shall get the long run. So therefore we conclude, come on, say, therefore the volume of gaseous product is 5.6 decimeters cubed. Please, if you try to compute this, you will get 5.6 decimeters. Okay, okay, cubed. Okay, so that's the impact is global warming. How do we mitigate it? By planting more trees. Simple as that. And I guess, okay. Now when you combine, you get 3, and realize that the total scores on that question is 12. 12, let's see that. We have 3 plus the 5, that's 8, plus, okay, plus the 4, that gives you 12 marks. And that marks the end of that question. See you in item 3. That is our next stop over. Okay, great. Don't forget to subscribe.